CPP. All right, so this was the CPP file that we ran for the box challenge. And I'm going to open up the associated make file. So whenever you create a new controller in C++, you're going to have to compile that program, right? So Webots once again uses something called make, and um, each controller requires its separate make file. So what this make file right here, I have it opened up. What this make file lets you do is you can set what exactly you want to build and with like what parameters. So for instance, down here, I have a file called main.cpp, right? And this contains my entire program. All I have in my make file is this cxx sources equals main.cpp. And that tells make that main.cpp is one of my build targets. And all of this is automatically generated. So it's very convenient. All you have to do is tell it what files you actually want to build. And once you do that, you can just hit the build button and it's going to call make within the console. And since this is already a built project, it's going to say there's nothing to build. If this is your first time building a CPP file, then it's going to compile and link the program, and it's going to produce your executable. So after you do that, make sure that your controller is set to the controller you just created. So for instance, mine is set to my controller because in our video demo, the controller we created, I named it my controller. And now I'm going to go over the actual code that we wrote in the video. So for the square challenge, we needed to rely on the motors, the motor encoders, and the gyro. So the motors and motor encoders, we use that to go a certain distance, right? And for the gyro, we use that to turn a certain amount. But there's a couple of nuances of the sensors and motors in Webots that you might find different from previous things you might have done, like Robot City or like NXT or EV3. For instance, let's talk about the motors. So the motors in Webots, they actually have two control modes. They have a position control mode and they have a velocity control mode. So what that means is that you can either set your motors to go a desired position and Webots will automatically run the motors until you reach a desired position, or you can set your motors for a desired velocity and Webots will run it for as long as you want at that certain velocity. So in this program, we're actually using velocity control mode, which means that we set the motors to infinity. And before we talk about the actual motors, let's talk about these include statements. So for every associated class you want to use, like the robot class, or in the motors or gyros or position sensors, you need to include the appropriate .hpp file up here. So you can see that we include robot.hpp because we're using a robot, as well as motors, gyro, and position sensor. And right here at line 11, what I'm highlighting is we're creating our robot objects. And line 12, immediately after that, we're creating our two left and right motor objects. So in Erebus, the robot that they supply to you, which is called a Pioneer 3DX, it has two motors. It has a left motor and a right motor. And these two strings right here, these just refer to the names of the motors attached to the virtual robot. You can find that under the robot. So in this case, we're looking at robot 1. You can find that in the scene tree under the robot, and then under extension slot is your available sensors. And you can see we have a gyro, receiver, emitter, light sensor, GPS, and camera. So the left and right wheel, these are actually on the base Pioneer 3DX, which means that you won't see this under the extension slot. What the extension slot is for is specifically sensors they've added onto the base robot that did not exist on the base robot. And if you go under gyro, you'll see that the name is gyro. So when we create our gyro object, you'll see it as gyro. And in order to find the names of left wheel and right wheel, you actually need to look under the Pioneer 3DX Webots documentation. And let's see if I can find that. Let me quickly share screen of my Google Chrome. All right, so this is the Cyberbotics wiki page, and they have a separate page for each of these each of these robots. You guys can see this, right? All right, good. Um, this is a description of the entire features of the base robot. So this is literally the name of the two motors, left motor and right motor, which are termed left wheel and right wheel respectively, and as well as the motor encoders, which are called position sensors. There's the left wheel sensor and the right wheel sensor. So whenever you have a question in general in Webots about your specific virtual robot, there's a guide page for every single robot they include as a proto. And let me switch back. Okay, so after you create all your sensors, down here in the main, and we talk more about this in the video, but everything within Webots requires you to execute a time step loop. And what that means is that for every certain amount of time the simulation elapses, you need to call this loop. If you don't call that loop within a certain amount of time, then your controller is going to crash. Because the way the simulation runs is that this loop must be called at a certain amount of time interval. In this case, I believe the time step is something around 32 milliseconds. And let's go back to talking about the other two sensors. So the gyro, I'll talk more about the gyro. You guys might have used gyroscopes in EV3 or NXT. And I believe that the NXT gyro gives you an angle measure in terms of 0 to 360 degrees, right? Or 359 degrees. Webots is different. This gyro actually models a real life gyro, and real life gyros, they technically only give you back angular velocity. So if you take in physics or calculus, then you know that you can integrate angular velocity in order to find angle, but that's a bit complicated. So we just provided a little function right here that gives you back, that integrates it for you. So all we do is we have a global variable called angle, and we add the amount of time that has elapsed from our time step multiplied by the instantaneous, or like the current angular velocity. And we update our angle every single time within our main loop. All right, and I'll just talk about the position sensor, and after that, I'll just run this sample program. So the position sensor, or motor encoder as most people call it, the units of the motor encoder are actually in radians. They're not, and I know for NXT and EV3, their motor encoders are in degrees measurements, but these are in radians. So once again, what we do here is in our function here, we have to convert the radians of the motor encoder and find out how far the robot goes in 1 meter, how many radians the wheels need to turn for the robot to go 1 meter, and we use that to calculate how much the robot needs to move or to a desired position. So I'll just run this sample really fast, and you guys can find an in-depth tutorial on this in the actual video that's on YouTube. But for right now, I'm just going to run the sample. So let's build. It's built. Set. All right. And I'm just going to run it. Okay, so we completed our box that the robot just navigated in. And this code is also available in our video description. I think we have a link where you can download the code and try it out yourself. I still, however, recommend typing it yourself because you build more memory by doing so. So take a look at the video and we'll take questions after. So Jeffrey, do you have anything?
Yeah, just a little bit. So one thing Victor mentioned that was very important is Webots runs this main loop over and over again, and you have to. That means you have to be careful with how you code and structure your program. So let me share my screen. Okay, so this is the basic outline of a Webots robot controller. You have your int main, you have your robot object, your time step, and your while loop. All of this was covered inside the video, and Victor had just mentioned it too. So you guys, if you have been programming in something else, something like Robot C or Visual Studio, you're probably used to main running sequentially. So if I want my robot to go in a box, you would probably do something like robot go forward, then robot turn, and then you loop this. And when you loop this code, when you loop these two lines 4 times, then your robot will go in a box. However, that doesn't work because Webots uses this while loop right here. And as Victor said before, this while loop has to run once every 32 milliseconds if time step was equal to 32 milliseconds. So that means you can't say go forward, then turn within this loop, or else that will exceed 32 milliseconds and you'll run into a bunch of problems. So one way to get around that is we created a state variable. If you run through our code, if you look through our code for the box challenge that Victor was just talking about, you'll see that we have a state variable. Basically what state variable does is, let's say we want to go forward. Inside of here, we would just turn on our state to, let's say, 1. And then up here, we would assign some commands to certain numbers. So let's say if I want to go forward, I just set my state to 1. If I want to turn, then I just set my state to 2. That way, inside my while, I can just say if state equals 1, then I'll be going forward. Otherwise, if state is 2, then I'll just be turning. And that gets around this while loop because when it first enters this, let's say state begins as 1, it'll hop into this while loop and it'll go into this if and go into your going forward function, and it'll make the robot continue to go forward. Then after it's done going forward, I can say if done going forward, I can say set my state to 2. That way now, when it comes back up the loop, state will now be 2. So it would actually hop into state equals 2, and it will begin turning, and it will continually loop and keep hopping into your turning code. So that way, you never block this loop from iterating. So if you want to get a better idea of how the state variable works, make sure to check out the code that Victor was talking about. It's in the description of the box challenge tutorial video that we posted, and there's also an explanation. So yeah, that's basically it for me. Victor?
I have nothing else unless, yeah, I think we can take questions now, Dennis.
Sorry, I was actually typing them in for you, Victor. If you take a look at Slack, you'll see some of the questions. There were a couple.
All right.
Actually, the very first one from Etosh, he actually said he resolved that. But the second one from Jeffrey W, he's saying he has an issue with the Webot just opens and stops responding as soon as I click anything. So actually, I don't know if you can actually solve that problem here, maybe afterwards, because it might be a bug, or unless you have an idea off the top of your head.
Yeah, I think we can, that's something we should probably look at a bit later because it's a very specific problem. Unless you have like any kind of error message that pops up, I'm not too sure. As in like it freezes immediately when you open it.
Yeah.
Yeah, we'll probably have to take a look at that later.
Yeah,
All
just
right.
hang around, and when everyone leaves, we'll let you share the screen and stuff.
Yeah, Jeffrey W. I wonder if it's the Jeffrey W I know. Jeffrey W. If yeah, just hang out after class or after this, and then we'll look at it. Aditi also asked a question. If you take a look at the next one.
Okay, can you share how to assign the robot controller in the scene tree? Sure. All right, I'm sharing screen again. Okay, so one thing I should clarify is if you have a C++ or like C controller, don't use the UI on this left-hand side. So this Erebus UI, you won't see it in other Webots programs, but specifically for Erebus. Okay. This load controller feature currently only works for Python. So since we have a C++ program on the right, don't use these two buttons. Instead, you want to go to the scene tree under your robot. So for instance, we're taking a look at robot 1, and you can see one of the fields is a controller. And if you want to load your own controller, then all you have to do is click on this, hit select, and it's going to pull up a list of controllers that you can enter. So in this case, the controller we wrote is called my controller, so I'm just going to select that and hit OK. And now your controller should be loaded. Make sure also when you load your controller that your world is completely reset. So make sure that you press the reset simulation button and make sure the world time is 0 and everything is paused. And you should be able to load the controller.
And after you load the controller, make sure you save your world.
Okay, hold on one second. I'm giving you another question. Actually, I'll just tell it to you. Isaiah asked, what C++ compiler do you recommend? I assume Webots does not come pre-installed with one.
You actually don't need to install any specific C++ compiler for Webots. The makefile should work automatically. As long as you're using the default text editor, then we shouldn't come into contact with any kind of compatibility issues or anything like that.
Yeah, I think if I remember correctly, it's just using like GCC compiler.
Yeah, MinGW.
Oh, is it MinGW, really? Oh, okay.
I think so, if I read their documentation correctly. I might be wrong, though.
Okay, all right. Etosh had asked the question. He said the left wheel set velocity is not working. I did post that up if you take a look at it in Slack. It's the last question. Do you see it?
Yes, I see it. Atosh, when you mean that the set velocity is not working, do you mean that the program doesn't compile, or when you run the simulation, the robot doesn't move? If you
Here.
could clarify that question, that'd be great.
All right, I just unmuted him. I think I just unmuted him.
It doesn't, the robot's not moving, but it does compile.
Okay. Left
Wait,
wheel.
it doesn't move or it doesn't compile?
He said it compiled. He said it just wasn't
Ah.
moving.
Okay. Did you do anything with your set position?
You can, well, you could talk, Itash, if you want. You're muted yourself.
I guess that's fine. I can just share my screen for now. So basically, how it works is you set all your motors up like this, like Victor said before. You have your left motor object and your right motor object. Then from there, you need to set positions. So how the set position works is the motors, whenever you set position, it sets a target radians of how much you want your robot to turn. So let's say your motor hasn't moved at all. That means it would have encoder of 0 radians or 0 degrees. I'll just talk in degrees for now. It makes things a little bit easier. So initially your robot has 0 encoders in it. And if I don't set position, and I comment it out, by default, I believe the set position value, the motor's target is also going to be 0. And if your motors are at the target encoders, then your wheel will not spin anymore. So for example, let's say I add these back in and my robot moves until it has spun to this target, until the motors have spun 20 radians. Once it gets to that, the robot will stop itself. So even if I continue to leave on my set velocity and I continue to set my velocity to 10, it's not going to go any past the position that you set. So what probably happen is if you don't set this position, by default, the position is going to be 0. And since your position is 0 and your motors start out with a target of 0, it's not going to go past your 0 radian target at all. So your robot doesn't move. So make sure you set position to some value, and then it should go forward. If you want it to go forward infinitely, you can just put some really large number, or you can type infinity in all caps. So once again, make sure you have all the components, the include file, like Victor said. You make your objects, you set position, and your set velocity. And if you have all of that, it should work.
Oh yeah, okay, makes sense. Yeah.
Okay.
We're going to the set position.
Okay.
Okay, there's another question if you take a look at Slack.
So what version of Python do you need? I believe it's anything after 2.7, Victor?
Yeah, I think it's 2.7 and 3.7. If you have problems with installing Python, I know I did when I initially downloaded Webots. Make sure that, first of all, of course, you need to install the right version of Python, but also make sure that Python, if you're using Windows, that it's in your path. And if Webots can't find Python due to it not being in your path, it's going to throw some kind of error where it can't like find Python.
And if that happens, uninstall, reinstall should hopefully do it.
Yeah, I was just looking online at the installation procedure and what the system requirements are. It doesn't actually say what version of Python you need here. That you would think they would, but it doesn't say. It probably says it somewhere. I just don't see it here. Okay, and I don't think. Yep, there's no other questions, so we're looking good. All right. So did you guys, we're almost at the 30-minute mark. Is there anything else you guys want to show or you want to talk about?
Oh, actually, yes. I'm going to share my screen once again. Share Chrome. Okay, so right now I'm on the Webots documentation page. So to get here, I believe I Google Webots, go to their website. If you go to documentation and reference manual, this pulls up all of their documentation for all of their functions that you will need. So I can go to nodes and API functions. So as you start to code, you'll probably need to use more and more functions that are available to you. And since we don't have that much time, we're not going to cover every single function that you may need, just the sheer basics. But if you want to start getting fancy, I suggest you start reading around in here. So in this list, they have a whole bunch of protonodes, or yeah, a whole bunch of nodes that have functions associated with them. So for example, if I find motors, here they list all the motor functions that are available to you. So as you start to play around with it, I suggest using as many of these as you see feasible, like any functions that you think you might need. I suggest you try it out and see what they do. And they do provide, let's go down. They provide a list of all the C functions, C++, and Python. So for any language, for pretty much any function, for all of their functions actually, you can just go to this documentation right here and you can start reading about it. And they have descriptions of, I believe, all of their functions and what they can do. So yeah, this web page is very, very helpful. So yeah, remember this.
So Jeffrey, I just got a question about how to use the ultrasonic sensors, and that would be where you would look, correct?
Yes, actually, yeah. So let's pull it back up again. Oh, by the way, by this Saturday, we're going to release another video, and inside that video, we're going to teach you how to use the sensors, and the ultrasonics are part of that. So keep your eye out and watch that video. We will have an in-depth explanation, but for now, let's see, distance sensor. There we go. Just like the gyro, you will need a pound include at the top of your program. Then, let's see, there it is. If you're using C++, they have enable. So just like the gyro, you have to enable your sensor, and then you can get value with this function. So if you want to go ahead and try this out for yourself, this is the place to look. But we will release a video explaining exactly how to work with all the sensors that you need for Erebus Aura.
Yeah. I'm sorry, Victor. I was just going to remind everyone. Next this Saturday coming up at 10 a.m. They're going to cover programming the sensors on Webots. Is that the primary talk? Is about sensor programming?
Yes.
Yeah. So actually he sort of showed you like the gist of where you can find the documentation, but they're going to go over it in more detail, probably ultrasonics and, other sensors, probably a light sensor, right, Victor? Okay. All right. Was there anything else you guys wanted to talk about? Because I had some logistical stuff to talk about.
Yeah, one more thing. I think Atash asked the question. So I'm just gonna warn you guys that the ultrasonic sensor is not gonna behave the way you might expect as in ultrasonics from NXT and EV3. I think the NXT and EV3 distance sensors give back centimeters automatically. The one in Webots is very different. It doesn't necessarily give you back distance. It gives you back actually a very strange range of values that we're going to talk more about in the next video. So I just wanted to mention that before Atash starts playing with it.
What exactly does it give you back?
I believe it's something with like the reflection of the ultrasonic waves off of the object. It's not purely distance because of the way they simulate the reflection based off of the distance, and they actually put it through like a noise generator, so it automatically generates noise in the sensor value readings you get back.
Yeah, so this is documentation. These are the values that it that'll return to you. So it gives back between 0 and 1000, well, 0 and 1023. So that's what you'll get
Oh.
back from the get values. Then if you just map it like according to this x-axis, that's the true distance to the wall. So actually, if you get back 1023, it's your robot's pretty close to the wall. And as the value decreases, that means you're getting farther away.
Okay.
So the documentation.
Do you know if that noise is randomly generated?
Yes, actually, Webots is very interesting in how it handles sensors. If you have a base sensor, then there's not necessarily any kind of noise. Since Webots' goal is to simulate real-life robots and sensors, they can take like a base sensor and they have parameters to add how much noise they want the sensor to have. They can add more noise or less noise, and they can restrict the capabilities of the sensor further to actually model the real-life sensor.
Oh, that's actually kind of cool, I guess. Might not be cool for the programmer, but it's kind of cool nevertheless.
I believe for the competition, there's no like plan to introduce noise. But yeah.
Okay. All right. Anything else, gentlemen? No? Okay. All right. I'm going to share my screen now, if that's okay.
Yep.
Real fast. So let me bring this up. Hey, who is that guy? Look at that. Okay. So this is the Storming Robots website. The only thing I want to show you guys is anything that pertains to the simulation that's going forward, primarily like with RCJ simulation and Webots. If you go to the website and come down and look at select events, there's a link there. This basically, Elizabeth's fancy animation brings up all the different videos that we're doing. This is basically the video series that we're doing now. So today's the 27th. We're currently doing this one right here. This Saturday, if I come here, you'll learn about individual sensors, and that's going to be May the 30th, this Saturday at 10 a.m. And all the other ones are going to be happening on Saturday as well. So on the 6th, June the 6th, June the 13th, the 20th, and the 27th. And you can see what the subjects are going to be for each one. The other thing I want to bring up is if you're, since you're all here looking at this, you're probably interested in doing this for RCJ. And if you're interested in what RoboCup Junior has to say in terms of like being notified, basically being on their mailing list for the simulation, there's a sign-up sheet here. This is actually put out by RCJ. I don't think we did it. So there's a link here on this page as well called Sign Up Here, and it brings you up to a Google Doc. And you can just sign your name, your email, region, name, your student, what you're interested in. Right now, we're doing the Webots Sim app, Erebus. There's also the VREP stuff. That is also another simulation platform that's for RCJ. So you can click. They only give you one option to click. I don't know why. You may be interested in both, but that's how they set it up. I do not believe we did this. I hope not. Anyway. So if you're interested in that, you're interested in getting on their mailing list, just go to this Google Doc link. And the link you can find, let's leave this. The link you can find, again, I'll walk through it. You go to our homepage. This is our homepage, basically. You come down and click on under select events, go to robotics simulation group, and then just go over here and click up where it says the RoboCup Junior has an email sign-up list. Just go under here, sign up here, and that will take you to the Google Doc that you can sign in, okay? Please only do it if you're age 13 or older. If you're younger, have your parents do it, and they can do it for you, okay? I think that's pretty much it. I don't think, let me see. Yep, I talked about Saturday, and I talked about the forum. So if there's no other questions, I guess we can kind of end this. Let me make sure there's no other questions here. Let me stop sharing here. Okay, yep, no other questions. So, all right, thank you very much. I guess Jeffrey W., you might want to hang around and they can take a look at your problem, okay? All right, thank you, everyone. It was good. Thank you, Thank you, Victor, and thank you, Jeffrey. Okay. So is Jeffrey W still here? Yes, he is. So hold on, Jeffrey W. I'm going to ask you to unmute, and you can just sort of talk to us.
Yeah, so I don't know, it's working now, but before, earlier today, when I was trying to open it, it would just like freeze up and not work. And then I tried restarting a bunch of stuff, and eventually it started working for no reason, and then stopped working for no reason again, and then whatever.
Well, is it dying now, or is it still alive?
No, right now it's alive, but
Oh,
I guess one thing to note is Webots is pretty taxing. Like every time I open Webots, my computer gets crazy hot. So
yeah.
those.
I opened what's a task manager. It's not using like all of the whatever CPU.
well, it's very GPU intensive, though, right? Like if you look at the specifications, they specifically say you should have a here. Hold on one second. So like here, for example, in the system requirements, they're basically saying make sure you have NVIDIA or OpenGL or AMD. The version of OpenGL has to be a minimum of 3.3. And yeah, I mean, it works okay on regular, you know, if you have a good, decent NVIDIA graphics card, it should be okay. Last week, someone was saying they had a problem because they were using it on an Intel graphics with an Intel graphics chip, like you normally see on a like a regular laptop, like a lower end or mid-level laptop. And I brought up my machine, and I have an RTX 2080, and the kid's like, well, I can't afford that. Are you crazy? And I'm like, yeah, you don't need to buy that. It doesn't need to be that nice. That might be the problem. So one thing you could do is when you try running it is, hold on one second. I don't know if you guys can you see my task manager?
Yep.
Okay, great. So you can come in and take a look at it, but you can also see what the GPU is running, right? And see, you know, how bad or how good it actually hits. So like if I try to run Webots now, all right, and whoops. So, I mean, I'm not doing anything really exciting here. It's pretty boring. So my GPU is basically sleeping. My Wi-Fi just went a little crazy, but in the memory and the CPU sleeping. But I'm eating up 11 gigs of RAM right now. Let's see what that is. That could just be Chrome for all I know. Yeah, it's Chrome as always. Chrome used to be a really great browser. Now it just eats everything up. Yeah, I mean, I don't know. I mean, it's actually hitting the GPU pretty well. I mean, to hit it at 41, 42%, that's actually pretty decent. Yeah. So you might want to look at that. I don't know if you looked at it or not. That might be the problem. Do you know what the GPU you have on your laptop or your desktop, whatever you're using? Jeffrey? I think Jeffrey fell asleep. Jeffrey, you're only supposed to sleep when I'm teaching class. Jeffrey? Oh, he says he can't unmute himself. All right.
Yeah, I don't think the GPU wasn't at anything crazy, but.
Okay, so you're saying it's currently running now, right?
Yeah.
Okay, how well does it run a simulation? Do you know what your frames? Oh, can you? Yeah, Victor and Jeffrey, can you see the frames per second when you run the simulation?
I don't. I think there's a way. Actually,
I thought there was a way to do it because
yeah. I actually don't remember how to do that.
Yeah.
But I remember seeing
I'm
like a
running
frame count.
like nothing because I haven't had time to put in any code, and it's getting to like 25%. Just like opening the world and pressing play.
Okay. You mean on the CPU is 25%, not the GPU, or?
No, the GPU is 25%,
Oh, okay.
or
Well,
like 20%.
well, that's
Somewhere
then
in there.
it's sleeping
Yeah.
then. Well, what about memory? How much RAM do you have?
Memory is fine. There's like 6 gigs in use out of whatever,
Oh, okay. 6 gig out of how much?
like 16.
All right. Sounds like you have a pretty decent machine. So I have a feeling. Well, what GPU do you have?
How do I check?
Oh,
There's,
well, just bring up a.
okay, I opened Task Manager, right?
Uh-huh.
There's GPU 0, which says Intel Aura UHD graphics, and GPU
Oh.
1, which says NVIDIA GeForce MX 230.
Oh, hey, can you share your screen then, and let's take a look at that real fast?
I can't share my screen, it's disabled.
Oh, did I disable that? All right. Well, guess what? I'm gonna re-enable that here. Or hold on a second. I think I'm gonna re-enable it. Hold on a second. All participants who can start sharing. Okay. All right. Can you try it now? Okay. So you're currently running. Yeah. You know what? Okay. You know what? You see, if you have 2 GPUs, oftentimes the program you run will bind to one of them by default. And maybe you're binding to the Intel one instead of the NVIDIA one.
Okay.
Hold on a sec. You know, man, I don't know. How do I do that?
I think it's binding to the NVIDIA one, because nothing's happening right now. And the other one has all my other stuff, maybe. I don't know.
Try running. Just try running Try running now.
Yeah, now it's at like higher. Both are higher. I don't know.
Yeah. I don't know. Hold on one second here. Where is that at? Come on, don't argue with me. Yeah, I don't have 2 of them on my machine, so I don't think I could even like try it. But I know that on my old laptop in the past, I would have it where I would go to run like say Photoshop, and it would bind to the Intel chip by default, and the thing would like run as slow as a dog. I'm like, what are you doing? And then I'd look and I noticed that, and I was able to tell it, don't do that, right? I don't think it was Photoshop. I think it was something else, because Photoshop's really smart about it. It knows to not allow that to happen. Let me see. You know what to do? Here. Let's bring up. This is such a. Okay, here we go. So let's do this. Properties. Yeah, I'll have to look at it. I'm almost sure that if you have 2 GPUs, it has to figure out which one to do. And your Intel GPU it did spike there for a moment, but so
you're doing anything.
Yeah, you're not running anything. Yeah, maybe it is okay. So if you click run, it ends up. Yeah, maybe it is running to your GPU. Hold on. Okay, but I mean it's working now. So
it's working now.
Yeah. Okay. Well, you know what, Jeffrey? I mean, if you keep having problems going forward, send us an email.
Okay.
Right. You know my email.
Yes.
Send an email, and I'll see if I can get an idea of what's going on. I don't know if that would be the problem or not. I was just kind of making a guess.
Okay.
Yeah, because we know the people who do the software for this, so
okay.
Maybe we can get something done through them. All right. All right. I think we're done. So if there's nothing else, I think we're going to close that. Oh, wait. Hold on a second. Wait, says Itash. Of course. You can turn down the graphics setting. Yes, I know that. He doesn't seem to be eating up the graphics setting though very bad. So he just said you can turn down the graphics setting. He says look above. Oh, he asked. You mean the map function? Here, Itash, why don't we unmute you? Or you know what I'm gonna do? I'm gonna.
There's like a map function in Arduino. Like you can map like let's say your joystick value from like 0 to 1023 to negative 512 and 512. Like, does that exist on like the Webots thing?
Yeah. Do you guys know what he's asking?
Sorry, what map?
Okay, so I'll ask. I know exactly what he's talking about. So in Arduino, there's a map function, right?
Okay.
So a map function allows you to take two numbers like 0 to 1023 and map it to something else like 0 to 100, right? Which is the common thing you would do, or the opposite, let's say. So like on Arduino, you when you do PWM for motors, you normally do an analog rate of 0 to 255, but let's say you want to map that to 0 to 100 to be 0 to 100%. So you could say map 0 to 100, 0 to 255, and then it'll return back the value, and then you pass it the value that you want to map. So you want to map, let's say 50, and that would map it to 127, which is half of 255. So he's asking if there's a map function.
No, I don't think there's at least I've never heard of any kind of map function within Webots.
Well, you have access to like STL and like any C++ library.
That's true. Also, does this Arduino map, is it only like linear?
Yeah, it is. It's only linear.
Okay, because also the sensor values to the actual like physical values mapping to the sensor values that Webots uses is not necessarily going to be linear.
Do you mean because of the noise? Or are you talking about the 0.2 centimeter?
Let me share my screen. So this picture is this graph is of like how they map the physical distances to like sensor values, right? So depending on the sensor, it's not necessarily gonna be linear, right? And especially because they add noise in, like this is the true line versus these are the range of noise that can be added. It's not necessarily gonna be linear in any case. So I'm not even sure using a map function would work, if that makes sense.
Wait,
Yeah.
I'm only using it to like reverse the value. So like you know how like a 1023 is really close to the wall? I was just gonna say map it from 1023 from 0 to 1023 to 1023 to 0. It just reverses the value. If you know what I mean. So like yeah.
Okay.
Well, let me. Here's what I'm going to say. I'm going to say two things about this. One, the map function, you can find it, right? It's open source. The map function, I've seen it. It's one line of code. You can kind of figure out how to write it. It's not that hard to write.
Yeah, I can actually go into Arduino documentation and find it. I think I've looked at it before.
Yeah, it is just one line of code though. It's pretty easy to find. I was going to tell you how to find it if you have Arduino already installed, but
I do have Arduino installed.
yeah, you can probably find it. Let's see, where would that be? Would it be in the hardware folder? Shoot.
Wait, put the equation in the chat so I don't have to like find it.
Well,
I don't know.
yeah. I mean, here's what. Yeah, I'm going to be like Miss Elizabeth. I'm going to say you should think about how to actually do the mapping, right? Because it's just math. It really is one line of code. But if you really need it, if you really want to know, or if you can't think about it, this will be your homework assignment. Your particular homework assignment is think about it, and then if you can't figure it out, come back this Saturday and we'll give you the answer. Because I actually I could probably just type it up real fast, but yeah, but you can also, just to let you know, you can also find it in the Arduino code. I mean, it should be easy to find. I mean, it should be, if you have Arduino installed, it should be right on your machine. I just don't remember what header files it's in. Probably, maybe it's not in hardware. Probably isn't in the hardware folder.
Yeah, okay. So I think I'm gonna leave now.
Okay, all right, thank you.
Bye.
Bye-bye. All right, unless there's anything else, I think I'm going to end this. Okay, so hold on one second. All right, because we still have 7 participants. All right, I'm going to end this, everyone, unless there's something else. Let me see in the chat. Nope, don't see anything else. No. All right, so I'm going to end it. Thank you very much, everyone. Victor, Jeffrey, you want to hang around, or you want to reconnect into a different room?
Sure.
To do a post-mortem? Okay. All right, talk to you later. All right, everyone, bye-bye. Guys, let's meet in like lab 5, okay? Do you know how to connect to lab 5?
Do you have the link, or should we go look for it?
All right, I'll tell you what. Here. I'll give you the link in just a moment here. I have it. Yeah, it's online. It's on the...
Oh, I have the link.
Yeah.
I'll send it to him.
Okay, you're going to send it? Okay.
Got it.
Here, I have a better idea. Hold on a second. I'll just do what I did last week.
Yeah, I was wondering.
I couldn't remember what I did last week. So I'm going to say, hold on one second. Everyone in waiting room.
Oh, you can't copy from the Zoom chat.
No, I know. It's